Okay, in this video, we're going to look at applications of right-angled triangles. Now, there's lots and lots of real-world situations where you can use right-angled triangles and the rules of trigonometry to find distances and find angles and directions and all kinds of things. We're only going to look at two particular applications of right-angled triangles in this video. We're going to look at how you can use them for finding angles of elevation and depression and distances that relate to angles of elevation and depression, and for bearings, which is another way of saying directions. So compass bearings, which direction on the compass should we head in? Alright, let's look at the first one, angles of elevation and depression. Okay, an angle of elevation is when you've got some kind of situation where you've got a flat horizontal line, and from that flat horizontal line, from one end or the other of it, some other point rises up from there. So, for instance, if I was looking at a flagpole, there's a flagpole here, and I want to know how high is the top of that flagpole, then I can say, well, here's the ground along the bottom here, and I'm going to draw a line from me. I'm down here in this at this end of the line. I'm going to draw a line up to the top of the flagpole. Okay, and the angle of elevation is the angle between the flat ground and the top of the flagpole. Okay, inside that little angle, inside that little box there, is this Greek symbol theta, which is always a symbol we use for an unknown angle. There are other symbols we use, but that's the main one, theta. Okay, so this is an angle of elevation. You can see why it's an angle of elevation, because we started at the ground and we went up. So we were elevating the line upwards and creating an angle. And once you create an angle of elevation, so to have an angle of elevation, you've got to have a flat horizontal line and then a raised line above it. Well, that looks just like a right-angled triangle, doesn't it? So we've created a right-angled triangle, and now we can use our rules of trigonometry to work everything out. As long as we know two parts, whether it's the angle or one of these sides around here, we can find out everything about that situation. And even if the flagpole wasn't there, if we just said, okay, we have a flat piece of ground and we raise up at an angle from it, an angle of elevation, we've got an angle of theta in there. We don't have to have anything along this side. We can just close it off ourselves and turn it into a right-angled triangle. Okay, so we can use angles of elevation to make right-angled triangles. That's angles of elevation. Angles of depression, it's the same idea. The only difference is we're starting from a horizontal line and going down from that point. Okay, creating a downwards angle. So we start from some horizontal line and we go downward from there. So the tilted angle, or in this, if you imagine it's going to be like a triangle, that's the hypotenuse. That's going to be below the horizontal. Okay, so that's an angle of depression. A situation where you might have an angle of depression is, say, you've got a plane up in the sky. I won't even try and draw a picture of a plane because I'm not a very good artist, but let's say this P stands for a plane that's up in the sky, and the plane's trying to get to this point down here on the ground. Okay, well, if you draw a straight line across to where the plane wants to end up and then go down, and then you connect those 2 points together, this is where it wants to end up, this is where it is now, then we get our right angled triangle. And the angle of depression is going to be from that flat horizontal down to the line that it wants to go on. That's going to be the angle of depression. Okay, it's critical whenever you're doing problems involving angles of elevation and angles of depression that you draw a diagram of the situation. It's not going to be possible to do a lot of the problems unless you draw a diagram. So that's essential. Okay, another thing to bear in mind is that both of these situations, angles of elevation and angles of depression, you can turn them into a bit of a rectangle, and it should be pretty clear if you connect the lines on around your diagram, turn it into a rectangle, you're going to have another triangle which is going to be very, very similar to the one you had at the beginning. Okay, if you look at what are these angles here and here, well, since this angle theta, that's the big one here, it's going to be the same as in there. This angle is 90 degrees, so this angle inside here is going to have to be 90 degrees minus theta. Okay, so we can work out what this angle here is if we want to. And since over here we've got another angle there, if that's theta in this corner, and this is a right angle, and they've all got to add up to 180, then this angle that's left over here is going to have to be 90 minus theta as well. Okay, so that angle is going to be 90 minus theta as well. This angle here is going to be theta. So that angle in that corner and this angle here in this corner are both going to be theta. So there's a lot of symmetry, a lot of pairs in these angles of elevation, angles of depression problems, and you can use that to your advantage quite often. So say you wanted to find the distance along here, along the top, you could obviously measure that out. If you were given the right bits of information, you could find out what that is, and that would tell you that this length along the bottom is going to be exactly the same. That's going to be x as well along the bottom there. So lots of symmetries in these problems. Okay, let's see if we understand it by doing a worked example. So we've got a tower, and the tower is 100 meters high. From the top of that tower down to a man who's standing some distance away, there is an angle of depression of 15 degrees. From the top of the tower down to the man, it's an angle of depression of 15 degrees. How far is the man from the tower? Alright, let's see if we can work it out. You remember that the first step is always to draw a diagram of the situation. So let's draw the tower. Okay, there's the tower. And we're told there's some man standing a distance away, so he's over here. There he is down there. And from the tower down to the man, there's an angle. If we draw a line from the tower, top of the tower down to the man, we're told there's an angle of depression of 15 degrees. So if we had a vertical line going, horizontal line going across the top, the angle from the top of the tower down to the man is 15 degrees. That's how to read that question. From this horizontal line down, it's an angle of depression, so we've got to go down from that horizontal. It's an angle of 15 degrees, we're told. So we've sketched the rough diagram of the situation. How far is the man away? Okay, so how far is that distance there, x? Well, that's going to be exactly the same distance as this distance up here, x. Okay, it's going to be exactly the same. And we're told that the tower is 60 meters. That's the other thing we've got to put in there. Tower is 60 meters, which means this side over here is also 60 meters. So now we've got a right angle triangle. We know one side, we know the angle in there, and we need to know this side x. So now we've just got a simple trigonometric problem which we should already know how to do. So from this angle to that other side, it's the opposite side, and this is the adjacent side over here. So we've got the adjacent side and the opposite side involved in this problem along with the angle. So if we've got A, opposite, and adjacent, then that sounds like a tan problem. Okay, so we're going to write out the equation. Tan theta equals opposite over adjacent. That's a very ugly looking theta, but it's a theta nonetheless. And theta is 15 degrees. That's the angle we've got in here. So theta equals opposite, which is 60 meters, divided by adjacent, which is x, the thing we're trying to find. Alright, if we know how to solve for x, we've got to get x on its own, times both sides by x. Then we've got x tan of 15 degrees equals 60. And then we've got to get x on its own, so we've got to get rid of this tan here. So divide both sides by tan of 15 degrees. And x equals 60 divided by tan 15 degrees. Okay, let's put that in. Okay, so here's our calculator. This is the bit that we need to put into the calculator. This 60 divided by tan to the 15. So let's put that in. 60 divided by tan of 15 degrees, and down here the calculator is set on 15 degrees, so that should work. Close the bracket and press enter. and we get told that it's 223.92. Now, because the 60 over here was in meters, that means this result will have to be in meters as well. So 223.92 meters. There we go, 223.92 meters. Alright, let's do another quick worked example for angles of elevation and depression. Okay, in this problem, we've got a helicopter which is trying to rescue two people in the ocean. So this is the ocean down here. And one of the people is located here at S1, the other person is located here at S2. We know the helicopter is 1800 meters above the ground, and we know that the angle from person 1, the angle of elevation from person 1 up to the helicopter is 60 degrees. From person 2, the angle of elevation is 40 degrees. These are both angles of elevation. Okay, now you can see, once you've drawn the diagram, you can see how it creates two right angled triangles. I'll colour them in different colours. Okay, so the first triangle is the green one here, which actually extends all the way to that vertical line at the end there. It doesn't just stop at this point along here. And the other triangle is the purple one there. So we've got two right angled triangles. Now we want to know the distance between the two people. We want to know the distance from S1 to S2. Okay, the way to work that out is going to be to find the distance from this point here to S1. We've got to find out that distance, that's called X. Then we've got to find out this bigger distance along the base of the green triangle from S2 to here. Let's call that distance Y. And that gap in between the two survivors is going to be the difference between X and Y. So we can find that by doing Y minus X. That's going to equal the gap. Alright, so what we've got to do is find these two values X and Y in order to solve this problem. Okay, first let's find X, the bottom of the purple triangle there. So we've got an angle, and we've got the opposite side from the angle, and we've also, and we're interested in finding the adjacent side. So opposite and adjacent, that's going to be a tan problem. So tan theta equals opposite over adjacent. Start by writing out the question, write out the equation. And the angle is 60 degrees, that's written here. So the opposite is 1800 over the adjacent, which is our unknown X. Now we can get X on its own by multiplying both sides by X. That cancels out the X here. Then we get, and then divide both sides by tan 60 degrees, and we're going to end up with, and that cancels out, X equals 1800 divided by tan 60 degrees. Okay, we'll put that into the calculator. So we've got 1800 divided by tan 60 degrees, and that gives us that answer. Okay, so we've found X. If we go through the same process for Y, I'll just jump ahead, I'll show you the working out, but jump ahead to the answer for that. We end up with this result, Y equals 1800 divided by tan of 40 degrees. So let's put that into the calculator. Okay, when we put 1800 divided by tan 40 into the calculator, we get 2145.16 meters. So that's the result we've written over here. Alright, so we've got X and Y. We've got X and Y, and now to find the gap between X and Y, we need to do Y minus X. So that's going to be 2145.16 minus 1039.23. And the calculator gives us, for that, we get this result here. 2145 minus 1039 equals 1105.93 meters. That's how far apart the two survivors are. Okay, so hopefully we've got a pretty good idea about angles of elevation and depression and how to solve problems that involve that. Alright, now let's move on to bearings. Okay, bearings, as we said earlier, are compass directions. Okay, they're ways of working out which direction are we heading using compass directions. So north at the top, then east, south, west. Okay, now there's two ways of expressing bearings. One is called the true bearing, and the other one is called the conventional bearing. And anytime you've got a true bearing, you can convert it into a conventional bearing, and vice versa. You can convert a conventional bearing into a true bearing. Let's look at true bearings. Okay, true bearings are measured in a clockwise direction starting from north. Okay, so whenever you're working out bearings, it's always good to draw a bit of a compass, and obviously north will be at the top. Okay, a true bearing will start from north, so start from this line here, and it will go around however many degrees the bearing is until it hits that point where it stops. And then whatever angle that's created, so in this case it's this big angle here, which is 180 plus whatever this bit here is, that's going to be the true bearing. Okay, so let's say I wanted to express 240 degrees as a true bearing. I wanted to see what that would look like. Well, I'd need to draw my compass, and then starting from north, from 0, I'm going to go around, and after I've gone down to south, I've gone 180 degrees now. That's 180 degrees. If I go all the way to this bit here, I'm going to have gone 270. So west represents 270, east represents 90, south represents 180, and west represents 270. If I went all the way back around to north, I'd have gone 360 degrees. But for 240, it's not going to make it to 270. It's got to be a bit less than that, but it's past 180. So it's going to be about here roughly. That's going to be a bearing of 240 degrees. A true bearing of 240 degrees. It's going to point in that direction. Okay, now once you've created a bearing, then you've got a triangle. Okay, once we've got a bearing, we can say we've got a triangle from there to there. There's a right angle triangle in there. We've also got another one up here. And in each of those right angle triangles, I know something about the angles. Okay, let me expand that and show you. Okay, because this true bearing was 240 degrees all the way around there. Okay, I know that at this point here, I had 180 degrees. That angle in there was 180 degrees. Okay, so left over in the rest of the 240, that's got to be 60 degrees in there. And since this is a right angle here, I know that this is 30 degrees. And from those two, I can work out what these are, if you know your complementary angles. So I can work out all the angles in this little situation by knowing that bearing. So that's a true bearing. And if you wanted to convert that into a conventional bearing, I'll show you how to do that. Okay, so for our example of 240 degrees, if we want to express that in conventional terms, okay, here's 240 degrees here. We've first got to measure from relative to north or south. Okay, so for this angle here, we've got to ask, is this line here, is it closer to north or south? It's obviously much closer to south. Okay, so the first part of our bearing is going to be south. Okay, next, now that we've established that we're starting from the south point, next we've got to head towards either east or west. We've got to measure the bearing towards either east or west. Okay, now from the south position, as we head towards west just here, this is the angle that we're measuring as we go from south to west, because we're measuring it first relative to north or south, then to east or west. Now from the south, it makes sense to go towards the west here, so we've got to measure how far is this angle in between the south and the bearing as it heads towards west. Since we know this angle was 240 degrees in total, that was the true bearing, and that would mean this half here has to be 180 degrees. Then what's left over from 240 after 180 is 60 degrees. That's got to be 60 degrees in there, since that's 180 all the way around there. Okay, so from south towards west, it's 60 degrees from south towards west, and then we write the west at the end there. Alright, let's do another one. Okay, if we've got a true bearing of 150 degrees, like we do here, this is 150 degrees. Okay, if we want to convert that into a conventional bearing, then we've first got to measure relative to north or south, So it's closer to south, so we'll measure relative to south. And then we've either got to go to west or to east. We're going to go from south to east, because it's on the eastern side. Okay, how far on the eastern side? Well, if it's 150 in total, then this is 90, and then this bit here must be 60 degrees. Okay, this gap in here, because 60 plus 90 equals 150. So if that's 60 over there, then this has to be 30 here, because that right angle's got to add up to 90. So from south, we're going 30 degrees towards the east. So that's the conventional bearing. Alright, let's summarize what we've learned in this video. Okay, here are the notes that need to be copied down. So make sure you copy those into your book. And that's all. Thanks very much for watching. I hope you found the video helpful.